Hey, welcome to today's video where I got a new project for you guys. It is another J1850 module, but this time we're emulating it instead of using a data link chip like this or one of the transceivers. This one is basically a discrete version of the transceiver, which will allow us to use all new parts, nothing obsolete, nothing that is coming out of the gray market for making this happen. That doesn't mean I'm discontinuing this project here, so don't worry about that. This isn't discontinued. I am going to continue to do it because I do like these data link chips. I think they work great. The only problem is they are obsolete. One day we'll run out of them. I'll keep supporting them as long as I can get the chips for a reasonable price. But, you know, there will be a day that comes where this is going to have to rest, because what are we going to do? Go grab old BCMs out of the junkyard and pull the chip out of them, or old PCMs from the 90s? And so this right here is a transceiver that is completely discrete, uses all new parts, and it is based on the Mecchina M2 design, or Mecchina. I don't know, it's Italian, I don't speak Italian, but yeah, it is based on that design, and it'll work with Arduino, and also the code is based off of Redhead Rod, code that he had uploaded to GitHub. So kind of used his code and the Mecchina design to get this up and running. And yeah, just, you know, let's take a look at this. I got one built here. Let's get a couple more of them built up, and then we can take a look at it and see them communicating. All right, so let's go ahead and get these soldered down. What I got here is my J1850 853 bottom heater. Yeah, it's a convection heater. I just have a little plate there, and then this has, it's vented on the side so it doesn't overheat it. And then the hot air station. I did hand dispense the solder paste, so we'll probably see some parts float around. But yeah, let's go ahead and get these on here. And yes, you could use a like an oven, a reflow oven to do this, or a toaster oven that you've programmed. You know, there are other options for this. Also, a hot plate works good for doing this. The hot plate I had off-gassed really bad from the fire retardant they used in it, and so I got rid of that one. I did not like it at all. Okay, so here's three of the boards we just worked after a little bit of rework and putting the connectors on. So as you can see with it, I used the 5 volt, 12 volt, and ground exactly the same as the other modules here. And then the TX is the reset pin, the fault is the chip select pin, and the RX is the interrupt pin. So basically I avoided all of your SPI connections from this, in case you wanted to drop one of these into an existing project where you were using one of these. Same exact footprint, very similar pinout, and that avoided your clock, your master out, and your master in pins. So that way this can just drop right in there. So I wanted to kind of give you a little overview there. There's no components on the back of it, same as this. So that way if you wanted it to be able to sit all the way down flush on your other board, that will work as well. Still no cancellations. And yeah, it's pretty much the same footprint. That way it'll work with it. Unlike these, it does not build its own 12 volts, mostly because I wasn't sure if this was going to work, so I didn't want to invest all the time laying that out in Rev A. I'm definitely going to do a Rev B of this. I may put the 12 volt boost converter on it. I have other plans of what I might do to it. And if I do that, it probably won't fit the 12 volts. So we'll see what happens there. But yeah, I intentionally left a lot of space on this board with the plan to do something else with that space. So here's the setup for the test. We have that XC68HC58 module over here to use mostly for the 12 volt supply off of it, but also so we have something to talk to. And then we have the module here. So for wiring, in this example, I have the TX pin on pin 9 and the RX pin on pin 8 of this Nano. And then ground's connected, and the ground is actually shared between the two, so I would need the second wire. I've had this question a couple of times on my videos, what's the second wire? It's ground, because yeah, it's a single wire protocol, but you do have to have a common ground between your two things. So if you don't have it shared throughout the breadboard, you would need the second connection. But yeah, so the fault pin is not hooked up to anything. It's not used right now in the library, but we can hook up a pin there and look at the fault. The fault is just looking at the 7.5 volts or 7.2 volts, and making sure it doesn't go below a certain threshold. If it goes too low, it'll show a fault on that pin. Basically, to make sure that we're not feeding into a short, because it should show up if we feed into a short or U2 hasn't failed. So that's kind of the purpose of that. We'll have the scope hooked up. Channel 1 will be hooked up here, which is just across the bus, and then channel 2 will probably hook up on the RX side, just so you can see what is coming out of that comparator. Okay, so let's take a look at what happens when we power it up. The code, what it's going to do is it's just going to try to send a frame as soon as it starts up. Okay, and so now let's power this up, and then I will refresh the scope here so you can see it. Okay, so what we're looking at there is on the blue trace is the RX, and then the yellow trace is the actual bus here. And you can see that our data is on there. You can also see that we have some high frequency ringing going on. That is ringing coming out of this inductor, I believe. I don't think that the original module from M2 from Mecchina would have rang like that, because they don't have a output filter at all on there. But this also is like exactly how they drove that FET, so it also doesn't have any wave shaping to it, which you are supposed to wave shape this protocol. So let's actually do that first. Let's mod it real quick, so that way we can get a little bit of wave shaping in there, and doing the wave shaping will make that ringing go away, I'm sure. And yeah, so we should definitely fix that before we go any further, because that is pretty high voltage there. Let me get the cursors out and see what we're getting to with that. So yeah, with the cursors, we can see that we are getting upwards of 12 volts. That actually wouldn't damage anything. The protocol does allow for like up to 20 volts on the bus, I believe. But yeah, 12 volts shouldn't damage anything, but we still need to fix this. That's not correct. There is supposed to be wave shaping. All right, boom, by the magic of editing, I've fixed it. It did take a little bit of iterating to get to, but the main things that y'all need to be aware of is I had to change R11, R10, and add some capacitance there. So basically what we're doing is making it take longer to get into saturation on Q1. We don't necessarily want to change it so drastically that we start changing the timing, but we do want to just kind of round off that top and bottom edge of the waveform there, so that way it's no longer really sharp. If you look at the protocol, it allows for a really wavy wave shape to it, and it's actually intentional. This mod will be incorporated into Rev B. R11's now 35.7K, R10's now 4.7K, and then this new capacitor is 100 picofarad. The sit resistor over here is 10K, which gets us to that 7.2 volts instead of 8 volts. Okay, so let's see what the waveform looks like now, now that we did the wave shaping. Okay, so we no longer have that ringing. Obviously, you can't really see the wave shape very much at this time scale, so let's bring it in and turn off channel M2. So as you can see, our corners are pretty well rounded here and there and very well there. We still have a little bit of a sharp corner there, but this is significantly better, and this was a easy mod to incorporate without having to get too complicated with it. This particular transistor has a very low saturation voltage. It's like 300 millivolts. So yeah, it's kind of difficult to do the wave shaping with the particular transistor, but this is way better. We're able to still keep our filter on the output there and get that wave shape. I'm sure some of the wave shape, or some of the lack of a wave shape in the beginning has to do a little bit with that inductor. But again, I'm pleased with that. It's significantly better than most of these modules you'll find out there. A lot of those Elm 327s and other DIY solutions do no wave shaping whatsoever. I don't think it's it's definitely not quite as good as the wave shape that you'll get out of one of these data link chips, and it's not as good as one of the transceiver ICs that are natively used in this protocol. So yeah, let's take a look real quick at the protocol so that way you can see what I'm talking about. Okay, so here in the protocol, it kind of explains what I was talking about. So you have that rounded corner there. All four corners are supposed to be rounded, and we're definitely rounded here, there, and there. And it's a little bit sharp there, but we'll live with it. But basically the point of this is to prevent high frequency noise on this single wire protocol. And then if you look, so your input high sides max is like 20 volts. So that 12.8 or 12.6 we were getting to would have been okay. It's not going to damage anything. But it's just, you know, it's undesirable to have that ring. So we fixed it. Let's take a look at the schematics. That way you can see what I was doing and how this thing works. Okay, so just like the other projects, I have a GitHub repository for this. So you'll go in and you'll see Rev A. Rev A is only gonna have the schematic available for it, but I'll do a Rev B and I'll release the board files and everything on Rev B. Rev B is not gonna come out until I sell out of the four Rev A's that I wanna sell. But once that's done, I'll release Rev B and that'll have this mod incorporated into the circuit board where it's fixing that wave shaping to it. So yeah, the schematics found here. The ones that I sell, I am going to ship them as built, so they'll have that ringing in them still, but the mod's explained in the video if you want to fix it, but it's totally unnecessary to fix. This is how the Mecchina M2s would have shipped. Here is the schematic, and so what I did is I changed the value of this resistor here, that resistor there, and then added some capacitance from here to there. And the point of that was to kind of drag on how long it takes to turn on or off this FET to kind of give it a bit of a wave, or this transistor to give it a bit of a wave. This transistor has just got such a low saturation point that it was pretty hard to drive it. I had to go like all the way up to like 37K, and then I did go down a little bit. So that way it would still turn off fast enough, but slowing down the turn on was difficult. And then yeah, so we have that PS fault is this comparator here, and the RX is this other part of the comparator. I really only did the fault one because I had half of a comparator that I wasn't using, so I just went ahead and incorporated it. And then we are generating 8 volts right here. When you put a 10K resistor in the sit resistor spot, it brings it down to like 7.2, which is a little bit more reasonable. Most of the devices are like close to 7 volts. 8 volts is a little bit higher than most devices out on the class 2 bus. And then, yep, so it's a pretty simple design here, and we have an output filter. The Mecchina M2 does not have a output filter, and then this one doesn't really have reverse polarity protection on this, but Rev B will have a TVS diode, a unidirectional TVS, so that'll give you reverse polarity as well as voltage suppression. I'm going to put a 12 volt TVS, even though up to 20 volts is allowable. But a 12 volt TVS is going to clamp around like 16 volts or so. So it'll either clamp around 16 or 19, I can't remember. But yeah, our clamping voltage will still be pretty close to what the max allowable is. So I think the design-wise, this board's gonna work. So now let's take a look in Arduino IDE and get an idea of how the code itself looks. And again, the code is in the GitHub, so you'll see it in this folder here, the source folder, and in the source folder you'll see an API description on how to use it. So in here you have the header and the C++. These are really the kind of the library per se, and then this this .ino is just an example of how to use that. You can set it up like a library in Arduino, or you can just put it local in the folder. That's how I was using it. I just put it local in the folder of your INO file. So let's go ahead and take a look at that in Arduino. Okay, so here is the source code, and again, it's all documented in GitHub, so I'm not going to spend too much time on it. But basically, you got to define what your RX and TX pin are. They are predefined as 8 and 9, so if you use 8 and 9, you don't actually have to have this define in here in the header file. It does define them if you didn't. So then you have just you have to instantiate the object and just kind of go through on it. This one's pretty simple. We're gonna wait for serial. That's mostly for if I were to use like a Pro Micro or one of the other microcontrollers that have a built-in serial, and then we initialize it. So we have a couple of variables in the initializing. We have the RX, TX, and if we have it in like debug mode or monitor mode or review mode. And then we send one frame during the setup. That was the frame that I was showing you on the scope. And then it sits here listening for data. And if it receives any data from another module out there, it's going to reply. So that's what's happening in this example. So yeah, in the C++, almost all of this was written by this red-headed Rod, and I did change a couple of things in here. One of the main things I changed was easy send. They were creating and destroying an object over and over again, doing in it, and it had a risk of heap overflow, but this time we have a buffer that we're using instead. So I just tried to change this to stack allocated memory, so that way it was less likely to have like a memory leak. So I did change this whole function and just completely changed that. And then I removed like the test mode. The test mode in it would like write with the RX and with the TX and look to see if something's on the RX at the same time. It was also just another thing that you could accidentally misuse. So I just went ahead and removed it because it's unnecessary, and that was something that would be pretty easy to actually do yourself by just writing, just doing like a digital write to the TX pin and then a digital read to the RX pin, and not actually need that mode. So I did remove that, and I changed all of the serial writes in here were were like the USB writes originally, so I changed them so that way they'll work with these older Atmega 328s. So yeah, I mean, I really didn't change a lot, so I can't take credit for writing this library. This isn't like my own unique work. So definitely credit goes to the original creator of this. And yeah, he didn't have any credits in there for himself. I went ahead and put them in and then put my edit in there. Oh yeah, well that's really enough on the code. Let's actually take a look at the bus traffic, but on here. So we'll look at the serial port and see what we're doing. So we're gonna have, first let me power up so that one is the other module, so this guy. So we'll go ahead and just put him in RX mode, and then we will just apply power to this one. And we'll see that we receive that frame. So if we compare it to the example code here, we're sending, 1, 2, 3, 4, 5, 6. And right here, we are receiving 1, 2, 3, 4, 5, 6. And remember, this last one on the XC68 is not actually a data bit. That is the status bit and the status code. So it now should have sent that again. And so when it sends it here, it's just going to show the CRC with this module, the way the firmware is written. And yep, you can see that it did send it a second time. So that's TX. All right. And we received that. And then we also sent that frame because it received data, so it sent this. So yeah, both the RX and TX are working on here. We were able to receive the data that I sent from one device and then send data back to it. So yeah, I mean, I'm pretty happy with how this project came out, especially since I didn't have to write the bulk of the code. I'm not a programmer, so it was really nice to be able to find code that worked. And since it had been tested on the Mecchina M2, I just kind of followed their footsteps on how they did it. We can take a look at the Mecchina module so you can see. Okay, so here is the product that I kind of based this off of. So I based it off of their interface board, which is a good deal if they would ever sell them. I've been wanting to buy one for like years, and they're just like never in stock. I've been looking for like 2 years for one of these to just be in stock on their website, because I'd like to support them and buy it directly from them. But yeah, so their processor board, they're using quite a large processor, and I think this is why they haven't been stocking, is they're having a hard time sourcing that. I'm not sure. I do know they've been having a hard time sourcing components for the M2, which is why they haven't been selling them. The A0 doesn't support this protocol, so that's why I haven't bought one. Those are available, but yeah, so this is the board I based it off of, and you can see the schematic for it. So a lot of the differences that you'll see in here are really just because this one can do both PWM and variable pulse width, and I only wanted to do variable pulse width. So I cut out a lot of the PWM stuff, but also they had a lot of unnecessary protections in there, like reverse polarity protection on every single pin of the IC, and then this was unnecessary because you want load on both sides. So you need a load resistor. Well, you're supposed to have a load resistor on variable pulse width here. It's to help with reflection and such. But yeah, you're supposed to have this load resistor, but the load resistor doesn't need to be unidirectional. Yeah, I got rid of that diode. I also changed the MOSFET because I just, mostly just because I had them on hand, and you don't really need a pull down on the MOSFET either. But yeah, I originally just like the transistor that's actually doing the talking, I did completely duplicate that circuit because I wanted my board to work exactly like theirs when I went to test it. So that way there was no questioning the code. That way, if the code didn't work, I would know that it was just a problem with the code and not a problem with my layout. But since it just worked the first time I tried, then I kind of wish I had changed this transistor out, something that had a little bit higher saturation point, so that way I could have stayed in that linear region with it longer, so that way it wasn't just all the way on. Because that's why it gets you get that square, is because you're now like all the way on, and so to give it a more wave shape to it, you want to be in the linear region longer. But yeah. So I did still use the LM317 in mine, even though I didn't need it. I could have just done like a voltage follower, but for the price, the LM317 is just so dirt cheap. It's just might as well use it. They needed it to be adjustable because you need to change the voltage for variable pulse width versus PWM. And then they needed the two comparators for the PWM, but since I'm just doing variable pulse width, I used the other comparator as a fault detection. So it was just because I had a free comparator, because they come as two on the chip. I just wanted to use it versus having it not do anything. They put a little more protections on here fuse-wise, but there's no filtering. And so yeah, I mean, it is a very similar circuit. I was just basically trying to copy it. But yeah, this was tested and worked. I knew it worked, so I went with it. I have tried other ones, like I've tried this one in the past and had no success with it. This particular circuit, I wasn't able to get it to work quite right. And also I was not able to get any like useful data out of it. Like the RX the N was definitely working. But again, I just couldn't get his code to work. Supposedly it works. I've actually emailed him and talked to him before, but I wasn't able to get it to work, and I didn't want to spend that much time on it. So yeah, I went with this one, which they sold the product, and there were people talking about using it in the forum for it, so I knew it did at least work. So I tried that. So I'm happy with that. I'm really grateful for that open source project, because this is all open source. So those schematics I was showing you, they uploaded them. So it's not like it's something that was leaked or anything. It's their open source stuff. So definitely credit goes to Mecchina for having an open source project like this, and that we're able to replicate what they're doing. And I would have just bought their product and showed it off on the channel, except for it's been out of stock for like at least 2 years. It's been like out of stock since COVID, basically, because they first came out with these things in like 2017, and I think in like 2019 they went out of stock and just really never came back. They moved on to the A0, which doesn't support the protocol that we're using. So you know, what else can we do? So had to duplicate it instead of buying what they sell. I know that Pete is doing something similar in the OBDX Pro. I've never taken it apart to know exactly how he's doing it. I don't particularly care to, because his is not open source, and I don't want to reverse engineer his product. You know, he spent a lot of time and money to make that, so I just didn't want to mess with his thing. So yeah, even though I am selling these modules and I completely kind of moved it to its own thing on GitHub, I'm not taking, you know, credit for this being like my original work. I definitely took heavy inspiration from Mecchina on that design there, and then that's all red-headed Rod's code. I mean, sure, I changed a little bit of it, but I didn't do anything spectacular. I'm not a programmer. I would definitely have not been able to write that myself. So yeah, I'm really happy with the way this project came out, and I just want to be sure that I am properly crediting the other people. But again, it's not replacing this project. So if you were invested in this project here, it's not like, oh, I'm abandoning this because we can now do it with an Arduino. It's more of just, I wanted another option for when the inevitable thing happens that those chips are just no longer available. There is another resource that is freely available. There are other products out there that are doing the same thing. Like a lot of the Elm 327 devices, they're just emulating it because they're, you know, the Elm 327s are long dead, and all of these are like, you know, clones of that. You take apart those devices, they all have different microcontrollers in them now. And then the OBDX Pro is emulating it as well. I've never taken apart his product, but I've seen pictures of it online. I do know for a fact that he's emulating it with the microcontroller and using a microcontroller that doesn't support it. I believe he's using an STM32 inside of his, it's definitely in the STM32 family. And those definitely do not support J1850 natively, so they're bit banging it as well. So this emulation or bit bang is what we're doing here. I'm excited to do another revision of this board, so hopefully I can sell the 4 of these that I want to get rid of first. And I still have these guys for sale, so just check the link in the description for my eBay, and you'll see I have you'll see the 2 different ways that I have this for sale, and then you'll see the one, because I'm only selling it with the connectors already installed. These guys, you can get them a little cheaper without the connectors, or just pay the full price and get it with the connectors. This will probably be about $5 or so cheaper. It's significantly cheaper to build that board, so I'll definitely have a price that reflects that. If you want to grab one, it helps support the channel, and it helps support doing more of these kind of projects. And then I'll get the second revision out. When I get the second revision out, I'll put the board files and everything up, so that way you guys can build them yourself if you want to, or you can support me by buying them from me. It's totally up to you. I like to make everything open source, so that's kind of just my take on it. But yeah, I hope you guys liked this video. I hope you liked the project, and I definitely have some more new projects coming around, so subscribe to the channel if you haven't already. But yeah, I'll see you guys in the next one.